Abe, would you like to read it? Or just...
Do you remember it? You can say it.
I took a screenshot. Didn't I text it to you?
Go ahead. You can do
All right, so this will be recorded. Now, officially, this was a student's answer. I am in no way condoning this. Number 8. When mommies and daddies love each other, they go into a room and, quote, fork, end quote. That's how a child is born. The reason to fork is because it sounds fun, but mostly because it feels good. There isn't a good reason not to fork. In his defense, he did write an official answer, but like later on in the test. So I'm sitting there grading this thing, and I'm saying to my wife, I'm like, I read it to her. We actually paused our show. Does he know the real answer? Does he really think that's what it means? I gave him a 0 on the whole test. Okay, now. So, wait, hold on. Oh, I have it here. Okay, good. All right, so first of all, and this is actually, I'm going to be yelling at every one of my classes this way. I felt like I made the, like the study guide, like pretty close to what the tests were. Wouldn't you agree? So when people leave questions blank, it kind of baffles me. Like, I mean, I expect it from Evan.
What do you want?
You didn't know what an interrupt
I
was.
think Evan's like my new target this semester.
Really? I hadn't noticed.
Really? Man, it would be worse if you were sitting up here. I would actually throw things. Yeah, I don't know. It was just strange to me as I'm reading through some of these. It's like, I don't even know. Like leaving some of these questions blank or like having completely horrible answers to certain things. I don't know. Having said that, this particular exam was better than some of the other ones. I think the class average for this was probably like an 82. 81, something like that. Okay, so let's just go through this and then we'll take any questions and go back to the slides. What is an operating system and why do we need them? Well, an operating system is a piece of software that sits between the user and the hardware. Why do we need them? Because hardware is difficult to use without software. You could have just said that. You could have mentioned the prior to operating systems, we had things like vacuum tubes where we had to manually manipulate hardware, that kind of crap, but the gist of what I was looking for is right there. Questions on that one? If you missed that one, I would suggest you drop. Hold on a second, I'm sorry. Okay, what are 3 goals of operating systems? Notice I didn't say what are the 3 goals. I was asking you to tell me 3 goals of operating systems. So any 3 goals would have been acceptable. So one goal might be to provide a convenient user interface, make life easy for end users. Another good goal was to keep the CPU busy 100% of the time. It's another good one. Another good goal is to provide corrupt-free file systems, file management. Another good goal is to maximize speed of memory management. Keep going. So really, any goals that involve any of our large systems, provide software drivers for third-party accessories, reasonable. Make sense? All right, questions about that one? Number 3, what was significant about the transition from OS 9 to OS X? X. What was the major problem associated with the transition? Well, the significance was that OS 9 was an operating system from the old regime of Apple. So OS 6, OS 7, OS 8, OS 9 were all kind of just evolutions of each other. OS X was when Apple took a jump to a brand new core operating system. They modeled it after OpenBSD. Well, actually, the core of it was the OpenBSD operating system. So they made a jump to a whole new software-based architecture. Initially, it was the same hardware-based architecture, but a couple years later, they even made a jump in architecture to go from PowerPC to Intel. But that's not the issue on day one of OS X. So the problem was that software that used to run on OS 9 did not run on OS X. So they had to provide the blue box, a virtual machine, which would allow you to run that software on your new machine at half the speed, bogging down the entire operating system, bogging down the whole machine because it was utilizing resources. So that's what I was looking for number 3. Questions on that one? All right, let's see. And actually, interesting enough, that was missed quite a bit too. Made that a pretty big feature in class, didn't we?
I think some of us didn't read the second half of the question and realize that there was a second question.
Oh well, yeah. So that was just stupidity. I'm talking about the folks that left that one blank or made something up. I thought we made a pretty big deal about the OS 9 to OS X transition. Okay, number 4. What is the Bootstrap program and why do we need it? That was right off the study guide, right? Pretty sure that was just on the study guide. Bootstrap is kind of the operating system before the operating system. Lives either in read-only memory or we can call it firmware, but it's the small program, usually written in assembly language, that loads the initial operating system into memory so that the operating system itself, what we've called an operating system, can actually load. All right, so something along those lines. Number 5, what is an interrupt and how is it related to CPU and I/O? This one was also missed a lot. So this dealt with CPU management. So an interrupt, when a CPU is chugging along, and remember, one of our goals of the CPU is to keep it busy 100% of the time, right? So we want it to always be crunching numbers, So in any case, an interrupt is when the CPU is crunching numbers and all of a sudden the program that it's currently working on has an I/O request. And an I/O request more than likely, well, not more than likely, will deal with reading something from the hard drive, reading something in from the user, or something like that. Something that's going to be time sensitive or time expensive in terms of time. So what happens is the CPU gets interrupted. That's what an interrupt is. The CPU gets interrupted. All the current data associated with that program have to get saved somewhere. It's called a context switch. Then that guy moves over to deal with the I/O, leaves the CPU to deal with the I/O rather than wait on the I/O, taking up that system resource, the CPU. Make sense? So that's what an interrupt is. That's how it relates to I/O. Because we don't want to have to wait for I/O while the program's still in the CPU. We want to let another program utilize the CPU while we're wasting time reading a file from the hard drive or asking the user to enter their favorite number or something like that. Questions on that one? All right. Compare and contrast USB and Firewire in terms of which is parallel and which is serial, and what that implies about the operation of the device. List one application that would benefit from each technology. All right. USB is a parallel technology. Firewire is a serial technology. So several people got those flip-flopped. Some people flip-flopped those words but still talked about them correctly after the fact. So parallel is bursty, sends things in 8-bit chunks. Serial is 1 bit at a time. It's it's a linear-based technology. So applications for each: parallel, kind of mass storage, USB mass storage type stuff. You could even have made the argument that I think somebody kind of made the argument, might have even been Haxton, about the average maximum speed is greater with USB in many cases. Is that you?
I don't think so.
No, well, whatever. Somebody gave a smart answer.
I don't think it's that smart.
That talked about, yes, it's bursty, but for mass storage type stuff, USB might be preferred.
Well, I said fast file transfer, fast efficient file transfer.
For Firewire, you might deal with encoding, video encoding, things like that, where it's less about the maximum speed and more about consistent speed. So it's not that Firewire is inherently slower. In fact, our modern day hard drives run off of a serial-based technology. Serial ATA is very much like Firewire in terms of linear bits being sent. So it's not just innately slower, but it is very consistent instead of being bursty. So people who do a lot of video editing and things like that could benefit from a Firewire-based device. Make sense? All right, questions on that one? Seven, what is the difference between L1, L2, and L3 cache? This was also missed a lot. You wrote a paper on this one. Oh, I'm out of anger juice. So, L1, L2 cache. Well, first of all, the speed. The fastest is L1, L2 is a little slower, L3 is a little bit slower. And the slower they get, typically the larger the storage capacity is. So you should say something along those lines. L1 and L2 live right next to the CPU cores, L1 being the closest, L2 being the next closest. L3 is not required. It's often found today because most of our CPUs today are multi-core CPUs. L3 cache is used to share information between cores. Okay, so it's a technology that deals with multi-core technology or multi-processor technology. Yeah.
You can't set a multi-process. So is it between cores or between processors or both? Is it on the motherboard between processors?
L3 cache did not come into existence until after we were dealing with dual core processors. So given that, I think the correct answer would be it's for multi-core CPUs, because the L3 would still live on the chip, the CPU, the actual chip. It wouldn't be part of the core. So when we look at a CPU, we're not actually looking at the processor. We're looking at a whole lot of pinouts and wiring and stuff like that, all pretty plated inside this big square. And it's the center of that, we have two little core dies or 4 core dies, something like that, if it's a quad core. So L3 cache would be for sharing stuff between those. But I pretty much accepted any answer that discussed L3 being a means for sharing data between multiple CPUs, whether it was multiple cores or multiple physical processors. I think I pretty much, as long as you mentioned something along the lines of that for L3, that's what I was looking for. Make sense? So L1 being the fastest is for really fast communication, L2 being a little bit less fast communication. So as a person who's writing ultimately the assembly language code for whether that's the compiler producing it or an individual, we get to choose which version of memory is most appropriate for the task we are about to create. If we need something even faster, that's when we go to hardware registers. Okay. What does the fork system call do? There's one advantage and one disadvantage of using it. Okay, and we already covered the answer to that. So, and this is actually, as much as we talked about this, people miss this one as well. When we talked about the fork system call, we were talking about it in parallel with threads, right? So threads are lightweight processes. What forking does is it creates a clone of a program, creates a clone of a full heavyweight process. So there's now 2 of them. One of them's the original, one of them's now the child. All right, so the forking system call is the old way of simulating, or the old way of what we call today spawning a thread. The difference is that spawning a thread happens within a single process. So it's that one process that manages all the worker bee threads. Whereas with forking, it's the operating system itself, the process manager that deals with each individual child, or each individual forked child.
There are laws against that.
Abe brought it up.
Technically, you brought it up today.
Huh?
Technically, you're the one that brought it up today.
Yeah, I wanted to discuss an interesting test answer. That's true. That's true. It was a funny test answer. So in any case, what the system call does is that this specific system called forking, what it does is it splits a process into two. So it creates a brand new process that gets its own CPU time, gets its own place in line for competing for the CPU and competing for memory and competing for the file system, all that stuff. So what's good about it? Well, what's good about it is it can be fairly high performance. Because now you have a program that instead of having to share, if you multi-thread it, instead of having to share its resources amongst all of its threads, now you get a program that can just duplicate itself, and now it gets twice the CPU time that it got before. That seems good, right? What's bad about it is it also has a much larger footprint, because with that responsibility, you're now a heavyweight process. You have your own memory associated with your own CPU time and all these other things that have to be stored about you specifically, so you're taking up more memory. It also creates a situation of being somewhat unfair to the other things on the system, right? And as easy as it is to fork a child, Abe, we could quickly write a program in C or C++ that bogs down our CPU very quickly by just continually forking off children. This is what we run into when we have all these deviant minds in the class. Abe.
I'm right alongside with you in line to go ahead.
Is it just because I'm like super overtired, but does it seem like we're worse when it comes to this stuff today than other guys?
I think about the same. Funny thing is, I stood next to Abe the other day in communion line. Church, so this gets taken care of once a week. Although I skipped church this week. Were you there?
I was at the men's retreat, so I was getting Jesus all weekend.
Yeah?
You were getting Jesus all weekend.
Let's not even go there. We're good. All right, so questions on number 8. Questions on number 8. All right, number 9. Why have peer-to-peer networks become commonplace for sharing data between end users on the internet? This was also missed a lot. And we spent, I think, close to 2 days talking about this, because it's actually a really fascinating topic with how things have evolved with how we share data. And many of us in here are experts at utilizing the internet for procuring stuff, digital stuff that you're supposed to go to stores and buy. All right, so
Download a card.
wouldn't download a car.
You've never seen that anti-torrenting pirating campaign?
Okay.
It's like you wouldn't download a car, and then they have like a video of someone like stealing a DVD,
Mm-hmm.
and then like you wouldn't download a car, so they're trying to like compare stealing
Yeah.
with like, and then someone found like a 3D model of a car online, and it's like
Totally can.
6 petabytes. They're like, I guess not.
With a large enough printer. What happened?
There's the
world's first 3D printing car.
Is it like legit?
Yeah.
I assume they had to drop an engine into it, or to print the engine too.
Or is it just like
I mean, well, it can print moving parts. You can have it do each individual moving part. You could print it and then assemble it.
It wouldn't last long with all the explosions inside of it. Gas. But it might start.
unless it's like a bicycle where you just like pedal and it just kind of like tends to go.
Yeah, we could do a 3D printed bike. Somebody's had to have done that.
Yeah,
Or a 3D printed parachute.
Try to get combustion going. Try to get combustion going in a 3D printed car. What happened to you today? My car melted.
3D printed bungee cord. All discount bungee. All of our bungee cords are 3D printed in my basement. Okay, so peer-to-peer networks. So in the early days, when you were to download a file off a server, you had one server sharing all the data from one central location. So let's say you had 50 people all wanting to download this big file. That one file would live in one place. All 50 people will be competing for that one place. Now, there's multiple disadvantages to that. One of them is, well, that is a piece of server software that's accepting those requests. And the more simultaneous requests, the more bogged down that server gets. So you can crash the software, crash the server. Beyond that, if we have those 50 people have a download speed, the speed they're going to try to maximize to download that file. Well, our download speed is that server's upload speed, split across 50 people. Does that make sense? So if you have even a cable modem at home, if you have the fastest, latest, greatest cable modem at home, let's say you're at 50 megabit per second, down is your download speed. Your upload speed might only be 5 megabit per second, and that's in today's world. So it's a tenth of what your download speed is. But let's say you were serving a file out of your computer. You weren't behind a firewall, something like that, so somebody could just hit your web server and download a file. Well, let's say you have 50 people all trying to download that file, and each of them has a 50 megabit per second internet connection. Well, they're all going to be sharing your 5 megabit per second upload. So 5 megabit divided by 50. Make sense? So it'll go a lot slower. So that's kind of the problem with the old client-server model. What peer-to-peer does is, so there's kind of two levels here that you probably should have talked about. I was a little bit easy on the grading, I think. Peer-to-peer shares the contents of a file amongst a large group of people. So when you're downloading the file, you're not downloading it from a single location. You're instead downloading it from many simultaneous locations, taking advantage of a pooled upload speed. That make sense? So it's a pooled upload speed. So right off the bat, it becomes more efficient. We're spreading the wealth of the bandwidth that's available for sharing this file. Secondarily, I guess you could also say we're also not bogging down a single server. There's also some security issues there, maybe even anonymous issues. When a torrent is created, it essentially creates a protocol for sharing some bits. And initially, those bits get seeded to the torrent. And then you have more and more people who start downloading and then resharing those bits. And eventually, as long as enough people are still enough people are still seeding the data, you run into a situation where you cannot necessarily go back and find out where this file started. The file just is. There might be 300 people all seeding the file. Make sense? So whenever you go and download your perfectly legitimate stuff, you're always looking for torrents with the most number of seeds, correct? Because they're going to be the ones you can probably download the fastest from. If you're looking for a file that has 1 or 2 seeds, probably going to be waiting a while, depending on how fast the internet connection was. All right, so that's one direction you could have gone with it. Another direction is dealing with my mind just blanked. Give me a second. Oh, firewalls. So if you live on a campus like this, and you have, the dorms behind a firewall or something like that, with a peer-to-peer network, you can have a central place that connects peers together. So both end users, if I want to share a file with Dave, we'll open a connection to a central point, and then that guy will connect our two connections. So we both opened our door, so there's no firewall to get through because we opened the door. So peer-to-peer networks also alleviate the problems of having to deal with security firewalls at places, since we are requesting the file rather than somebody coming and getting the file. Does that make sense? So one person can request to send a file, another person can request to retrieve a file through a peer-to-peer network. All right, so those are kind of two directions you could have gone. Probably should have gone both, but whatever. Number 10, how does memory management differ between different types of operating systems? Is there a best kind of memory management? Explain. Not only was this on the study guide, there was also a specific question that came up in class about what I was looking for here, and we talked about the difference between a multi-user and a single-user operating system, DOS versus like a Unix. So, memory management differs between a single-user operating system like DOS and a multi-user operating system like Unix in that the goals of memory management change. In a single-user operating system, DOS can say, oh, well, single-user, single-programming operating system, we're going to load the entirety of the person's program into memory. We only have to have enough memory to run the single program they're currently running. So we're going to make decisions for that single-user operating system that are in line with making that one user happy. In a multi-user operating system like Unix, even we look at the simple case where it's a single programmed operating system, so each user gets to run one program at a time. Now we have more than one user we have to make happy at the same time. So we have to make memory management decisions that are in line with that. We're going to have to split our memory up into more individual pieces so we can load more than one program into memory at once. Okay, so this is going to reduce the maximum size of any single program, or it's going to increase the required size of memory. One of the two, probably both. Make sense? Is one better than the other? No. Really depends on the goal we're trying to solve. All operating systems are not created equally. Number one here, we talk about the generic version of what is an operating system. Why do we need it? Well, different operating systems are trying to solve different problems. A single-user operating system is trying to make a single person happy, and it can make decisions that are compatible with that goal. A multi-user operating system is trying to make many users happy at the same time. Well, it has to make decisions that are compatible with that goal. So those are two very different things. And usually multi-user operating systems run on beefier hardware that's going to at least have a fighting chance of making larger numbers of people happy at the same time. Make sense? All right, so that's kind of where we were going with going forward for number 10. High grade was 100. Low grade was like a 20 something. Yeah, it was not good. So if you bombed it, I guess, try to figure out why you bombed it. If you come back and do well in the final, I'll work something out so we can replace your midterm grade or large portions of your midterm grade with however you do on the final. If you didn't prep for it or forgot about it and showed up and just bombed it, well, that happens. So fix it next time. If you really think you're not getting this stuff, maybe come and talk to me and we can evaluate whether or not this is the right gig. So any other questions on the test? All right, those are yours to keep. If you think I didn't give you points for something you think you deserve points, I'll come up right after class and I'll take a look at it. And typically I'm a pretty fair grader, but if you really think I ripped you off, feel free to ask. I'll fix it if I agree. All right, so let's get back to our slide set. All right, so I think did we just start? Did we just start talking about virtual machines?
Yeah.
Okay. So let's talk about those a little bit more. So virtual machines being a piece of software that simulates a computer. So it's a computer simulation in software. All right. And it allows us to run an operating system within an operating system, identically to what happened with the OS 9 to OS X transition, where they included that thing called the blue box. Okay. Interestingly enough, Since then, it's been very, very, very difficult to emulate a Macintosh operating system inside of a virtual machine. That becomes the challenge. You know, for many of you PC users, where you have plenty of resources on your machine. So for you don't have a Mac, right? You have nice PCs. So wouldn't it be nice for when you needed to do something Mac-wise, if you can run VMware or something like that and emulate the OS X, even if it was 2 or 3 versions ago or something like that, it'd be reasonable, right?
Oh yeah.
I mean, he's got the hardware. It's not that a Mac hardware is any better. It's the same crap. He's got plenty of RAM to split between a bunch of virtual machines. Probably you've got to do at least a dual core, probably a quad core.
Yeah. It's newest i7 or something.
Okay, so a nice quad core with hyper-threading, so technically he can pretend to share 8 processors. You know, he's got the system resources, but Apple won't let the virtual machine makers allow you to virtualize the Mac operating system. Now, having said that, it is possible. There are a couple of how-tos out there where I'm not sure if you can do it with VMware, but there's a couple of other kind of open sourcey type virtual machine software out there that has some tutorials on getting OS X running on a PC. I think it's pretty slow, because I think there's some hoops you have to jump through, but it is possible. It's just not convenient. It's one of those things that, on one hand, from Apple's perspective, it works exactly as the way they want it to work. But from a normal user's perspective, where maybe you're 90% of the time PC, 10% of the time Mac, should you really be forced into buying a Mac that you're going to be booting into Windows 90% of the time? That doesn't seem to be fair to a consumer, right? But the flip side is that with a PC, there's so many different hardware configurations that the Mac operating system doesn't have drivers for. But if Apple were to release their own virtual machine where they had virtual drivers for their hardware, which mimicked their own hardware on top of your hardware, there probably is a reasonable market for that. They could probably charge a pretty big premium too, wouldn't you think? Apple could probably sell the Apple virtual machine for $350, something like that. I bet you they could sell that for people who already have a nice PC that want to have Mac capabilities supported. Yeah, probably a decent business. So I'm sure all the high-ups at Apple watch my lectures, so they should take this into consideration. So in any case, virtual machine is a operating system that or a computer that runs in software that can then run a hosted operating system. So the end game would be that you could be running Windows 8 at the same time as you're running the Mac OS. So I run VMware on here, in theory. Oh, good. See? So how am I supposed to handle that? Okay, I can't even launch it to update it. Well, got to throw money at it, right? Or hit the torrents, to beta test. In any case, historically, I've run VMware Fusion. Look at him. Apple puts the nice little, no. Give us more of your monies. But I do have Windows 8 as a virtual machine on here that I'm sure I can launch again once I've paid money to update my VMware Fusion. It's actually very funny that I want to see what they're charging for that. Let's just go right to Fusion's site. You want your Fusion to work with... Oh, Fusion 7. What are they going to charge me to upgrade that guy? Only $50.
Unless you want Pro.
Oh, Pro. What's Pro?
I want Pro.
$80. What? I don't even know what the difference is.
It says Pro.
Yeah, seriously. Does it change the key features? No, these guys stay the same. So it really just might be Pro. Just add Pro to it.
Also included.
Huh?
Does it change the also included?
No. Only thing that changes this page is the price.
Click on Pro and see what it says. No, if you go under products, or you were under virtualization.
All the same great features. Takes virtualization on the Mac to the next level with powerful features designed for advanced users, developers, and IT admins, with leading-edge desktop virtualization features.
Well, you don't have a desktop, so.
Yeah, seriously. They really didn't say much in here. They just said just better stuff,
Faster.
better crap. Oh wait, oh, new is 150.
Wow.
Man, that's an expensive thing. No wonder people torrent this.
Yeah, let me get my system on top of that.
Yeah, seriously. So you torrent the
You
virtualizer.
can just, I don't know if Oracle has VMbox on
Yeah, I know. It doesn't matter. I'll just update it. My wife uses it for I rarely in Windows unless I'm doing Visual Studio stuff. But in any case, a virtual machine would be used to run a third-party operating system. So, for instance, if I needed to test something on Internet Explorer, or I was trying to hit a website that had an ActiveX control on it, which only runs in Internet Explorer. So ActiveX is kind of our Microsoft's approach to Java applets. So sometimes you'll run into a website, less and less often, but sometimes you'll run into a website that has an ActiveX control that says this requires Internet Explorer to work, right? So if I don't want to have to boot into, so the Mac supports Boot Camp, where I can literally restart my computer and launch Microsoft Windows as the native operating system, not virtualizing. I'm running it as the native operating system. If I don't want to have to do that just to use a web page, I can launch Internet Explorer through VMware or through the other popular one for Mac is called Parallels. Both of those are commercial companies. There's a bunch of open source ones as well. But in any case, then I can just launch Internet Explorer. And what becomes interesting, I actually think this is the button for it, so I wonder what even happens. Yeah, see, this sort of kind of works. It's not going to let me launch it, but you can set it up in what's called Unity mode for VMware, where you don't actually have to launch the full operating system. You can just go in here and say, oh, I want Internet Explorer. Behind the scenes, it'll launch the operating system, but it'll just give me Internet Explorer as a Mac application window. So,
That implies that someone would want Internet Explorer.
what's up?
That implies that someone would want.
Well, I just gave an example of when you might need it. Just because you don't want it doesn't mean there might not be some situations where you need it. See, look at that. I tried to launch Internet Explorer. It didn't even yell at me. It's not very friendly. It's not a user-friendly experience at all. I'm sitting here waiting. Just watch it launch. Now, only our main launcher tells you that you're not running the right operating system. If you really don't want to give us your money, just launch it from the Unity panel. It's cool. Okay, so advantages of virtual machines is that they run on top of your current operating system, so you can run two operating systems at once. Probably not going to do this long term, but if you needed to accomplish something quickly, or you were doing something on the Windows side and also were doing something on the Macintosh side kind of at the same time, or flipping back and forth between the two. Let's say you're a web developer and all your tools are on the Macintosh side, but often something that web developers have to do is they need to test their web pages to make sure they look right on all the different browsers. So with that in mind, you might have the virtual machine up and running, in the background, so that whenever you needed to test the web page, you can jump over to the Internet Explorer and see if the page looks right, something like that. Downside to virtual machines is they do take up a lot of system resources. So you have to dedicate so many cores of your CPU to the virtual machine, so much of your RAM to the virtual machine. And what it does is it grabs those system resources and holds on to them to dedicate them to that virtual machine. So people who run virtual machines often run them on pretty powerful computers. If you were looking at like those Mac Pros or something like that, one of the things we talked about is kind of an advantage of if you were going to spend 10 grand on a computer that has 16 cores in it, or even more with the the 12 core with hyper-threading. So that'd be 24 functional cores if you got the maxed out Mac Pro. What are you going to do with 24 cores? Well, you can convert video really fast. That's one thing. Something that would take a iMac an hour to do, you can do in a Mac Pro in 3 minutes because you have so many cores being thrown at the problem. But another thing it can do, having that many system resources, is you can run many virtual machines. You throw 32 gigabytes of RAM in there, and all of a sudden, with all those processors, you can have several virtual machines running simultaneously, each one being a quad-core virtual machine, and still have cores to spare. So that would be an advantage of something like that if you wanted to have a lot of virtual machines up and running at once. So if you were a developer, you were testing for many different systems, or you were dealing with, if you were a developer for kind of a cross-platform type of experience where the server runs on Unix and something else runs on Windows, and you have a client for the Mac and maybe an iPhone and an Android one, and you want to run all these different things at the same time, having a machine with all that horsepower potentially could be beneficial to give you a work environment that's not going to be constantly, where you're not constantly rebooting into stuff. Okay. All right. Virtual machine history first appeared commercially in IBM mainframes in 1972. Long time ago, but this would have been kind of baby versions of virtual machines. This was dealing with virtualized COBOL programs more than likely. Fundamentally, multiple execution environment, different operating systems can share the same hardware. They're protected from each other. So this is also another advantage of virtual machines, is that if you are working with a system that is, if you're working on something that is vulnerable to viruses, or potentially you're modifying the operating system in some way and you were writing, some unsafe programming, if you do that inside of a virtual machine and you have the original last working state of the virtual machine backed up, the worst that happens is you screw something up, you can just restore your virtual machine to the last working state pretty easily and you haven't lost anything. Kind of an advantage. But virtual machines are protected from each other. So if your Windows 8 virtual machine gets a horrible virus where everything's getting deleted, that's not going to impact the Macintosh side of your computer in my example, or your native Windows 8 side of your computer for a PC user. Let's see, some sharing of files can be permitted or controlled. So most of our modern virtual machine systems, so when we talk about like VMware and Fusion, really those almost become kind of the concept of a distribution, similar to operating systems, where you have the virtual machine in there, the thing that actually hosts the virtual operating system, but then you have all these tools for the host operating system. In my case would be the Mac operating system, and the guest operating system, Windows. Those guys become linked with some tools that are provided by VMware or Parallels that allow us to share files between them, drag and drop, share USB drivers, things like that. So in that respect, they become more like a distribution where they're giving us tools that make life easier for that as well. Let's see. Commutate. New word. Pretty sure it should be communicate with each other. Other physical systems via networking. So a lot of times what you can do is you get to choose how you want networking to work with your virtual machine. I would show you if mine would even launch here, but there's a setup for every virtual machine where you can say, how do you want the network to be set up? Do you want to bridge your current connection so it's available to both? Do you want to set this guy up, this virtual machine up, as if it was a client of this machine? So creating almost the environment of a local area network where the virtual machine can only connect to the host computer. It doesn't necessarily have internet access to the whole world. That kind of stuff. Let's see, useful for development and testing. I already mentioned that. Consolidation of many low resource use systems onto fewer, busier systems. So let's just say, let's take Concordia as an example. So would you agree that Concordia's website probably gets hit far less often than Google's website? Sure. Concordia's website probably gets hit more often than your personal website that you made in 150. Okay, but it's not a high traffic website. So could we arguably have our web server and a couple of other things sitting on the same physical piece of hardware here at Concordia? Arguably we could if the hardware was beefy enough. So we might have a single physical computer that has some virtual machines on it. One is our web server, one is our, let's say, mail server, something like that. Just using those two examples. Where we could run them both on the one physical host operating system, but we might want to have different configurations for each of those. We want to have their own environment. You know, maybe our web server has its own set of permissions and our email has its own set of permissions, and we want to have different patch levels for the operating system, or one of them runs on Linux, the other one runs on Windows. We can actually have those hosted on the same physical piece of hardware. So we can compress multiple individual, what typically would be hardware servers, onto one powerful server that had enough system resources to share but could still pick up the slack. Okay, let me just read this last point and then we'll stop. Open virtual machine format. Standard format of virtual machines allows VM to run with many different virtual machine host platforms. So, for instance, if you have been using VMware and all of a sudden it stops working on your current operating system, and then you go and research and find out that Parallels has a better deal, I could take my existing VMware operating system and launch it in Parallels, and it will just convert it over to its format. But there's a standardized virtual machine format that is kind of at the core of all of those. So if I have a VMware set up, I can go on to Parallels and it will convert it for me. All right. Questions, comments, concerns, bribes. Like I said, if you have questions about any of the grading on your test, come up. I'll take a look at it. Otherwise, I'll see everybody on Wednesday.